Today we're going to talk about piecewise functions. The admission prices of an amusement park are as follows. Children 5 years and under are free. 5 up to 12 is $5. 12 up to and including 18 is $12. And adults are $18. Find the admission price for a person of a given age. A 20-year-old is considered an adult, so they are $18. A 15-year-old is considered an older child, so they are $12. A 2-year-old is free. A 37-year-old is an adult. A 13-year-old is an older child. A 9-year-old is a younger child. A 12-year-old and including, so they are a younger child. And I feel like this is a typo, but that's okay. Alright, write a function rule that gives the admission price for any given age. We're going to need to write a piecewise function because there are going to be 1, 2, 3, 4 different prices. So we're going to start f of x equals, and remember x is going to be our age, and we have our 4 different prices. So the first price is free, the second price is $5, then $12, then $18. Well, when is the price free? It's free when you are 5 years old and under. So we're going to say 0 is less than or equal to x is less than or equal to 5. We can just say x is less than or equal to 5, but we really don't want to have any negative ages, so we're going to put a 0 there. So this inequality represents all the ages between 0 and 5. Costs $5 if you're older than 5, so we're not going to put an equal to symbol there, and up to and including 12. Older than 12, up to and including 18, and adults are over 18. So here's our piecewise function. Graph the function, then state the domain and range. Okay. So what we have to do is create a series of steps, or a series of constant functions. So our first thing we're going to do is we're going to put down the 0, and that's for 0 to 1, 2, 3, 4, 5. So if you are 0 to 5, it costs nothing. So we're going to put closed circles on 0 to 5, and we're going to fill in that it's free. Okay. Then we need $5. So I'm going to make my scale go by 5s. 5, 10, 15, 20. So it's going to cost $5 if you're older than 5 up to 12. So I'm going to put an open circle at 5, 6, 7, 8, 9, 10, 11, 12. And a closed circle at 12. And connect. So if you're anywhere between 5 and 12, it's $5. Alright, so now we're $12. So 10, 11, 12. And we're going to put an open circle at 12, and that's up to 18. So here's 12, 13, 14, 15, 16, 17, 18. So we're going to put a closed circle here, and this section of the graph represents that if you were from 12 to 18, it costs $12. And the last one is $18, so this is 15, 16, 17, 18, 19, 20. So this would be 18. Let's say it's about there. And I'm going to put an open circle here, and anything greater than 18 years old has this price. So here's a graph of our piecewise function. The next thing we're going to do is graph some functions that are already defined for us. And the ones we're going to graph, well, actually, that's not true. The next thing we're going to do is we are going to evaluate some functions. I'm only going to do a few of them, and then you are going to be on your own. So for number 13, we look at this function for f. We're looking for f of negative 4. So we have two choices. X can be less than negative 2, or x can be greater than negative 2. Well, because negative 4 is less than negative 2, we are going to put it into 5x minus 1. So 5 times negative 4 minus 1 is negative 21. Number 14, f of negative 2. Okay, so the next one is f of negative 2. Negative 2.
1 minute.
Mr. Ward, you're bothering me. Alright, f of negative 2 is going to fall for number 14 if x is greater than or equal to negative 2. So it's going to be negative 2 minus 9, which is going to be negative 11. F of 0, 0 is less than negative 2. So again, we're going to use 5 times 0 minus 1, which is going to give us negative 1. Again, the first thing we want to do is determine which interval our x value falls in. F of 5. 5 is greater than negative 2, so we're going to use the second function. So it's going to be 5 minus 9, which is negative 4. Take a second, pause the video, and do the next 4 problems, and then I'll put the answers up for you. Okay, the answer to number 17. Oh, wait, I have a mistake. 0. Whoops, I recopied this wrong. I did this one wrong. Uh-oh. That's why you're not feeling well, Ms. Strauss. 0 is not less than negative 2. I hope someone caught that. 0 should be greater than or equal to, so it's really 0 minus 9 equals negative 9. Sorry about that. Okay, so the answers for this one are going to be negative 9.5, negative 7, negative 15, and negative 10. All right. The next thing we're going to do is graph some piecewise functions. We're going to graph 2 together. The first thing we're going to do when we graph these is we're just going to graph each of the 2 lines as if they weren't piecewise functions. So we're going to graph 2x. 2x has a y-intercept of 0 and a slope of 2, so I'm going to go up 2 and over 1 a whole bunch of times, and I'm going to make my line. Okay, but I don't want the whole line. I only want when x is greater than or equal to 1. So I'm going to go to 1, I'm going to go up, and that's equal to, so I'm going to make that a closed circle, make it a little more obvious. Then I'm going to take my eraser, and I only want greater than. So everything less than 1, I don't want. So I'm going to erase everything that's less than 1. And now I have this piece where I have the graph of 2x, but only when x is greater than or equal to 1. So the second part is negative x plus 3. So here's plus 3, and down 1 over 1, down 1 over 1, down 1 over 1 would give me this graph. But I only want this graph when x is less than 1, not equal to. So I'm going to grab my eraser again, I'm going to go to 1, and I want to keep the part that's less than 1. See, all these x values are less than 1. And I want to erase the part that's greater than 1. And the fact that these 2 graphs meet in the middle like that, that's a nice coincidence. I'm not going to erase that red point. Okay, number 2. Again, I'm going to start by graphing the entire line x plus 6. So I have my y-intercept at 6, and I have a slope of 1. In this graph, I want when x is less than or equal to negative 3. So I'm not actually going to draw a line, I'm just going to back up my slope. Less than or equal to negative 3. Well, here's negative 3. I'm going to make that a closed circle. And which part needs erased? Well, this is the part where all the x values are less than. So this is the part that needs to be erased. Negative 2/3 x minus 3 if x is greater than negative 3. Well, here's my y-intercept at negative 3. We're going to go down, did I switch color? Yeah, down 3 or down 2 and over 3. I'm going to back up the slope a little bit because I want that when x is greater than -3, so I'm going to back it up 1. If I back it up any more, I can do that. So I have to be really careful with the erasing. Okay, so I only want this when x is greater than -3. So at -3, I'm actually going to erase that. I'm going to make it an open circle at -3. And I want everything that's greater than -3, so I want to keep this area where the x values are greater than -3. I want to real carefully erase all these parts where it's less than -3. So there's my graph. The last one we're going to do is another piecewise function, but this one is all constant functions. Constant functions are really easy to graph because all I have to do is say, okay, -1 to 2, so -1, 3, closed, 2 is open, connect. That's all you got to do is connect them. 2 to 4, so 2, 5, over to 4 and open. That one's 5. 4, my toolbar. 4 to 9 is 8, and 9, 11, 12. So that is how we graph piecewise functions.